In Elixir, a process is a lightweight concurrent thread of execution. Unlike operating system processes, Elixir processes are extremely lightweight in terms of memory and CPU usage. They are managed by the Beam VM, the Erlang virtual machine, which enables Elixir to run thousands and thousands of these processes concurrently with minimal overhead. Processes in Elixir are isolated from each other, meaning they run independently and have their own memory. They communicate through a mechanism known as message passing, where they send and receive messages asynchronously. This architecture is a cornerstone of Elixir's fault-tolerant and concurrent design, allowing for robust, scalable applications. Each Elixir process has its own stack and heap. And because of their isolation, one process crashing will not directly impact another, contributing to the system's overall resilience. This makes Elixir particularly well suited for building distributed, fault-tolerant systems like web applications, where managing many user sessions simultaneously and reliably is critical. It's really easy to start a process. Let's open up our terminal and start an IEX session. Make this a little bigger for us. And if we just do IEX, there we go. Creating a process is really easy. All we have to do is use a function called spawn and then pass in a function or anonymous function. In this case, we'll start an anonymous function and then what we want it to do. And since I'm just demonstrating how we start a process, we'll just have it sleep for 3 seconds. And the underscore is just for readability's sake. You can do it with or without. I like doing it because it's kind of like a comma and you can see what you're doing. All right. And then we haven't finished off this anonymous function, but if I return down, we can also just do an IO puts so we know when this process is completed. And we can just do order processed. All right. And then let's go ahead and end the anonymous function and then close off the last parentheses to spawn. So now when I hit enter, we're kicking off a process and it's going to just run in the background. And when it's done, we'll see a print statement from IO puts in the terminal. And there we go. 3 seconds later, order processed. Really cool. It's as easy as that to kick off a process. It goes and does work and will finish when it finishes. Now, obviously, our sleep here is just a way for us to simulate work. This could be anything asynchronous, like running a credit card transaction, communicating with our database, for inventory levels, emailing receipts, you name it. You probably noticed we got a response back that doesn't really tell us much. That PID is the process ID, and that allows us to check in on a process and send messages to it. We'll get into messages in the next video, but for now, I can show you how we can see if a process is still running or not and using resources. And all we have to do is, so since we didn't save our PID, our process ID, into a variable, we can just call it. So if we did v opening parentheses from line 1 and hit enter, we can grab the returned value from IEX line 1, and that is our PID. Okay. So one thing we can do process.alive ? And then we can pass in line 1 response, which is our PID from the last process we ran. And this will return a Boolean to us. And it's false because our process already ended. After the 3 seconds, it printed our order process statement to the shell. Let's go ahead and run this same code, but we'll increase this to 10 seconds just to give us more time to check on the process, okay? So if we'll set this to a variable this time, PID equals, so we're grabbing it and we don't have to grab the result from line 4. And then we're just going to go ahead and do the IO puts again, and we'll say order processed, and then we'll end that anonymous function and close off our spawn. So now when I hit enter, this is going to kick off our process, and we'll only have 10 seconds to see if it's alive. And obviously 10 seconds is a pretty long time, so we'll have plenty of time to check, but we should get a true Boolean back when we do that. So if I hit enter, now this process is going. And if we go to process.alive and send in our variable PID and hit enter, now we get true. And I almost missed our 10-second window. So now if I do that again, we get a false because the process ended. So that's pretty cool. We just created our own process, and now we know how to check to see if they're still running or if they've completed their process. So let's go ahead and close out of this IEX session. Whoop. What? Not now. I meant to do Control C. All right, and let's go ahead and create a new project. I'm going to just do it on our desktop, make it easy. And we're just going to do mix new, and we'll call this process order, okay? And then we can just cd into that directory. And now let's open up VS Code with this project. All right, let's close this welcome and expand lib and open up our process_order.ex, and we can delete our hello world function. And we are going to just create a similar process to what we just did in the shell. We're going to create a function. We're going to call this function process_order. And we're going to do the same thing we just did in our shell. We're going to just do a sleep. So process.sleep. We're going to sleep for 10 seconds. And then we're going to just do an IO puts so we know that it's complete when it is. And this will say order processed. All right. So we have our function, and now we need to call it with spawn, just like we did in our Elixir shell. And we're going to create another function here, and we'll call this start process. All right. And then inside of this, we'll do our spawn, and then we'll do our anonymous function. And all we have to do from our anonymous function is call our process order function. So process order, and then we can just do end, and there we go. And we don't need to have process order since this is our process we're spinning up, but we don't need access to it outside of this module. So I'm going to make it private. All we are going to have to do now to start our process order here is call our start process function. So save it, and then let's go back to our terminal, and we can just do a recompile. What is going on? Oh, I need to spin up our terminal or our IX. So IX -S mix, and this will compile our project and boot up the shell. And now I don't have to recompile because it already did that. And now all we have to do here is call our start process function. And I'm going to save it to a PID variable so we have access to our process ID. And then all we're going to do is say process order.start process. And now when I hit enter, this will put it into our variable, and it starts the process. And so if I did process alive PID, oh, it's false because I missed it. So our order processed, and we can see that right there. So if I run this again, and I'll be a little quicker on checking to see if it's alive. When I hit enter, there it is true. Now let's create a way to spin up thousands of simultaneous processes at the same time, we can demonstrate how fast and efficient Elixir is.
Hi, I'm Jacob. My YouTube channel and podcast reach thousands of engaged Elixir developers every month. If you're looking to promote your developer tools, services, or job opportunities to a focused audience of Elixir professionals, head to elixirmentor.com and let's discuss sponsorship options.
Let's jump back over to Visual Studio Code and let's just create a new file. And we're going to call this our process spawner.ex. Okay, this is just going to be a little helper module for us that is going to loop through and create 10,000 of the same process for us. Okay, so let's go ahead and just create a function here, and we'll call this spawn processes, and then it will take the number of processes we want to create. And now inside of this, all we have to do is we can just loop through 1 to however many processes we're creating. So if we do 1 ... and then number of processes, and then we can go ahead and pipe off of this. And so for each process, we want to go ahead and start a new process. So we're going to just go ahead and do a anonymous function, and I'm going to just return down, and then we can just call our process order dot start process. And so what we're going to do here, why is it yelling at us? Oh, it needs to take a variable. So just put an underscore in there because we're not using it. We just want to loop through 1 through 10,000 or however many processes we're creating. So what's happening here is we're going to go 1 through 10,000, and then for each number we pass into our anonymous function, we're going to start a process. Okay, so save this. Before we actually create 10,000 processes, let's take a look at how many processes are currently running so we can actually see we truly create these, right? So if we go back to our terminal, we can actually see how many processes are running with do a colon Erlang. And this is just using built-in Erlang function. And we can do dot processes, opening and closing parentheses. And then this, so if I hit enter, we're going to just get a whole list of every process running, but it gets cut off, right? So we don't even see them all. But we just want to know how many processes. So we can actually pipe off of this and just call length. And now it'll tell us how many processes are running. We have 63 processes. So now after we run our spawn code, we should have 10,063 processes for 10 seconds, right? So let's go ahead and do a recompile. And now if I call process spawner dot spawn processes, and let's go ahead and pass in 10,000. Like, that's a pretty big number, right? Now I'm going to hit enter. Okay, boom, it created 10,000. Now if we go ahead and look at the process length or the count, look at that, we have 10,063 processes running. And then there we go, we get 10,000 responses that they all finished and they all ran concurrently. So processes enable concurrency. So imagine we have like a big Black Friday sale or something and we have tons of orders being processed, but they could all take different amount of times, and we don't actually care if they finish in the order that they come in as long as they are processed. So let's go ahead and refactor our code a little bit so we can see when specific orders finish processes. So we will add an order ID to them, and we'll customize the output a little bit so we can see that they're out of order. So let's go ahead, jump back into Visual Studio Code, and let's go to our process order.ex. And the first thing that I want to do is I want to, for start process and for order, we're going to take a variable or a parameter here, and it's going to be our order ID. And then we're going to process that order ID. So we're going to pass it into our process order function. So that means we have to accept that parameter down here. So order ID, and what order ID is going to be is just our count, so we're already, when we spawn new processes, we're going to just pass in that 1 through 10,000. So we just have an identifier for each process. Does that make sense? I think it makes sense. So now what we want to do is, instead of working all orders, we don't want every order to take 10 seconds to process, right? That doesn't make sense, because every process, or people's internet speeds could all vary. So things are just going to go at different speeds. So let's go ahead and just make a processing time variable, and we're going to just randomly have this be from 0 to 5 seconds long. Okay, so we can do :rand dot uniform, and then we're going to just pass in 5 seconds, which is 5,000 milliseconds. All right, so now we have a random working time. So this process, we don't know how long it'll take. It'll take either 0 seconds or 5 seconds or 3 seconds, whatever random number we get back. So now let's pass in our processing time to sleep. And then for IO puts, we want to say that we want to know what order got processed and in how fast the time it was processed. So we're going to go ahead and just pass in our order number here. So our order ID. So order 1 processed in, and then we'll pass in our processing time. So processing time. So now we'll know how long it takes, and we'll just do milliseconds after that. So now when we kick this off, we're going to see like order 1 finished in 5 seconds, but then we could see like order 100 processes before order 50. So you're going to see that they're all utilizing, concurrent processes, which is pretty cool. So, all right, we refactored, we're passing in an order ID. So now from our spawn, we have to pass in our order ID here. So this is our order ID, which is just going to be 1 through however many processes we're booting up. All right, so order ID, save that. And now if we go back to our terminal, we can recompile, and we can call spawn processes. We're going to do 10,000 again, and we're going to see, everything process at the same time, but concurrently. So it doesn't matter at the order they were created in. And here we go. And look at that. We're seeing all these order numbers. So if we scroll through a little bit, look, order number 7928 processed before 4568. And then look, it processed, a couple milliseconds faster, which is pretty cool. I think this, and look how fast it zipped through. Like, we just processed 10,000 orders, all, with their own resources. So imagine if one process crashed. All these other processes are still going to finish. Utilizing concurrent processes to handle multiple order processing operations, as demonstrated here, significantly enhances both the overall performance and user experience in several ways. One, it improved responsiveness. By handling each order processing operation in a separate process, the system can manage multiple operations simultaneously. This means that a user doesn't have to wait for other operations to complete before their request is processed. As a result, the application feels more responsive and faster from the user's perspective. And another one, better resource utilization. Elixir processes are lightweight, and they're designed to make efficient use of system resources. So by distributing tasks across multiple processes, the application can make better use of available CPU cores. This parallel execution makes the system more efficient compared to single-threaded approach where tasks are executed sequentially. It also increases throughput. Concurrent processes allow the system to handle more requests in the same amount of time. This increase in throughput is particularly beneficial in high load scenarios, such as like sales events or peak shopping hours, where large numbers of user requests need to be handled simultaneously. Kind of like how we just did 10,000 orders all at the same time. And then you have your fault tolerance and isolation. In Elixir, each process is isolated, meaning that an issue in one process, such as an unexpected error, won't directly impact others. This isolation enhances the overall stability of the application. So if a shopping cart operation encounters an error, it affects only that specific process without bringing down the entire system, thereby providing a more reliable user experience. And then we have scalability. The concurrent processes model scales well with increasing load. As more users interact with the system, it can spawn more processes to handle the additional workloads. This scalability ensures that the application maintains its performance and responsiveness even as the number of users grow. User interaction fluidity. In a shopping cart system, various operations like adding items to the cart, updating quantities, and checking out can be processed in parallel. This fluidity in handling different operations simultaneously leads to a smoother and more interactive user experience. And then this also reduces latency. Since operations are processed concurrently, the time taken to complete each operation is reduced. This reduction in latency is crucial for operations that require real-time processing, like stock updates or price changes. Leveraging Elixir's concurrent processes for handling shopping cart operations leads to a more efficient, responsive, and robust application. This directly translates to a better user experience with quicker interactions, reduced wait times, and a more reliable system. So with that being said, I will see you in the next video.